Alright, so now we're in chapter 31 and we're going to be talking a little bit more about weather, and we've talked a little bit about it having to do with oceans and so forth, but now we're going to actually get to the weather part of it. Alright, now, whether or not you're ready, here we go. We talk about air pressure. We talk about where high air pressure tends to be fair weather. Low air pressure might mean that there's moisture coming in and so forth, and you might get rain. So air pressure is one of those important things. It's measured with a barometer. The simplest barometer would be a mercury barometer, which has a long, about 3-foot test tube. Okay, full of mercury. It empties into a little thing down here at the bottom. Okay, it's full of mercury, and the tube would be full of mercury. Okay, originally it was completely full, then they flipped it upside down in a container full of mercury down here at the bottom, and basically the weight of the mercury pulls it down, creates a vacuum in here. So the vacuum, since air can't get in and take its place, it won't let it fall down all the way. But it goes down a certain distance. Now, if the air pressure pushes on the mercury down here in the bowl, it will move this up, and we say the mercury is rising, which means air pressure is higher. If the air pressure is less up here, then it will fall and come back down here somewhere. Okay, so we talk about the barometer falling, rising, or being steady, staying about the same, and that has to do with the air pressure. And generally, like we said, high air pressure is clear, sunny weather, usually. Low pressure is going to be more chance of clouds and possibly precipitation and stuff like that. Okay, so that is air pressure. Now, besides air pressure, another major thing is humidity, which is the amount of water vapor in the air. Okay, we talk about the humidity, if it's humid outside. Okay, now, it's just the amount of water vapor. Now, we'll notice we say water vapor, not water droplets. Okay, actually water vapor, which is a gas. Okay, and the water vapor is a gas, and how much is in the air? All right, now usually when we talk about the humidity outside, they say, oh, it's 5 or 10%, or it's 20%, or if it's in Houston, it's 95%. Okay, the percent is, that is the percent humidity, and that means how much, what percent of the total it could hold. Okay, the percent of the total water vapor the air could hold. If it is 95%, that means the air is almost saturated. It's almost full of water vapor, and it can't hold anymore. This is why if you're in Houston, it's 95%, or anywhere it's 95%, but we'll pick on Houston. You're sweating, and your sweat can't evaporate very well because the air is already full of humidity. It can't hold any more water vapor, so instead of evaporating and cooling off your body by absorbing heat from your body, it just sits on your skin, and you just feel sticky, we say, because the sweat won't evaporate. Okay, now notice this percent of what it could hold. How much it could hold depends. If the temperature goes up, if it's hotter, then the amount of water vapor that the air can hold increases. Okay, and so hot, sticky weather in the summer, that's why, because the hotter it is, it can even hold a lot more. If it's colder, like in the wintertime, it can't hold as much. Okay, now, if the relative humidity reaches 100%, then some of the water vapor will begin to condense and form back to water drops. Okay, so when we have dew, or if it's really cold, we have frost, or if it's up in the clouds where it's really cold, you might even get snowflakes. This is when water vapor changes directly into a liquid, or in the case of frost or snowflakes, it's forming back into a solid, and that occurs when the humidity is 100%. Now, notice during a rain, on the other hand, the humidity may not be 100%. Okay, it may be less than that. It's usually going to be pretty high during a rainstorm, but it may not be 100%. 100% means that dew is forming on things. All right. Okay, now the temperature at which that would happen is called the dew point. Okay, the dew point is the temperature at which dew would start forming. If the dew point, for example, right now, say is 55, then that means if we could lower the temperature of this room to 55 degrees, dew would start forming everywhere. Okay, and basically this is what's happening when you get a glass of ice water and it starts forming dew on the outside of it, or condensing water. Why? Because you've got the air right next to that glass of water so cold that the water vapor that's in the air is turning back into water droplets, and you're basically forming dew. All right. Now, one of the reasons humidity is important is because water vapor is what forms water droplets, or moisture, which can lead to rain, snow, and heat, sleet, hail, all those other types of precipitation that we talk about. Okay, but in order to form, it has to precipitate. It has to fall out of the sky, and first it has to form very small water droplets, which get together to call clouds. All right. Now we have several different clouds. We have very wispy clouds like up here. These are called cirrus. They're usually very high level. And because cirrus clouds are very high level, they very often contain ice crystals. Sometimes if they're in front of the moon, for example, it'll make like a little halo effect as the light from the moon reflects off of those ice crystals in the clouds. So these are known as high clouds because they're very high up. They tend to be kind of wispy looking. You can see this example over here, excuse me, and they're very wispy, ice crystal-y clouds, very high clouds. All right. Now we have some other clouds that are called stratus. Stratus just means layered. They tend to come in layers. All right. Very often they are solid, the whole sky. You may see some like these that are just with little gaps between them, or up here, but they may just completely cover. When we have a completely overcast day, usually these are very often are stratus clouds that are covering it. Now, if you have medium height clouds, they would be called alto stratus. Alto kind of is medium. If you remember, you have the sopranos which sing the high notes, and bass and tenor are the guys singing the low notes. Alto are kind of in the middle. So the medium clouds a lot of times will have alto stuck on it. So if you see alto stratus, that means the middle. If they're just stratus, then they may be a lower level cloud. All right. Now, so stratus clouds would be generally low. Alto stratus would be in the middle. All right. Now the last ones are the clouds that we say have vertical development. So they could be on several levels. They may start fairly low, but they can build up into higher levels. And the main ones for these are cumulus clouds. All right. Cumulus clouds are the big puffy white ones, the ones that kids draw in elementary when they're learning how to make clouds. You just make a little puffy cloud, a little cotton ball cloud. All right. But cotton ball clouds have a tendency to build into storm clouds or thunderheads. And as they do that, it has to do with their vertical development. They start getting taller and taller, and as they get taller and taller, they tend to get flatter on the bottom, and we have what we call anvil clouds. Okay. But basically, they become darker and darker because they're getting bigger and bigger water droplets, and these eventually are going to become thunderstorms. Okay, now when they become big like that, they're called cumulonimbus. Nimbus has to do with clouds that might involve rain. So anytime you see nimbus, you know we're talking about a storm cloud of some sort. Cumulonimbus are kind of the ultimate ones, very often with thunderstorms and tornadoes and so forth like this. This one is building into cumulonimbus, although that's not quite the picture. You can see some of them starting to get some vertical development, but they're not really big and stormy yet, but they're getting there. Okay, and so cumulonimbus, if you see nimbostratus, nimbus, there's that nimbo again, so that means a rainy cloud, but it's a layered cloud instead of the tall cumulonimbus here. All right, we'll first talk a little bit about how clouds form. First of all, in order for water vapor to form up in the air, you need what's called a condensation nuclei. Okay, we don't like having a lot of dust and stuff in the air, but actually dust particles and such like that allow something for there's like solid here, and it allows a water droplet something to attach onto and condense on, just like when you have a cup of cold water, we said it condenses on it. Well, you need something for them to condense on, and this is what gives you that opportunity. All right, condensation. Now, as these atoms run around these water molecules, if they're fast, they just hit each other and bounce off, but if they're going slower, then they may condense. They lose energy, and they may condense and form water droplets. Now, these are very tiny water droplets, so when we see a cloud, it's made of these tiny water droplets. All right. Now, the water droplets are heavier than air, so they would normally just fall down. But if they fall while they're still very small like this, they will begin to evaporate, and before they get much out of the cloud, and long before they hit the ground, they will evaporate and be gone. Poof, and they're done. All right. But fortunately, in clouds, there is an updraft, which pulls them up. All right. And as long as the updraft is pushing them up more than gravity is pulling them down, then they will continue to hit water molecules and get bigger and bigger. But at some point, they're going to get to where the updraft equals their weight and they're not moving up anymore. And once they get much longer than that, they get big enough that now they're actually way heavier than the power of the updraft to keep them up in the air. And so they will begin to fall, and then they fall as raindrops. Now, if you have a very strong storm or very strong updrafts, they can get up very large. And if it gets cold enough, if they get high enough and cold enough, they start to freeze. And this is where you get the big hailstones and stuff. The updrafts are so strong that even large hail up to the size of grapefruit and stuff may still be getting tossed around up there and adding more and more water and ice to them to get bigger and bigger. Okay, but at any rate, at some point they get pushed up enough that they get enough water droplets that they weigh more than the updraft can keep them up in the air, and they start to fall down, and that's what we call our precipitation. All right. Now, another thing you may hear talk about is air masses, and where these air masses come from. These are large areas of mass that air that move in as a group because of the pressure differences, usually from high to low pressure. But you have these different groups, and depending on where the air mass comes from, determined is it going to be cold or hot, and is it going to bring moisture or is it going to be dry? Okay. So, for example, here we're in the United States. Okay, if Texas is in here somewhere, and if we see a right there, if we have a continental polar, continental tells us it formed over land, Canada basically, all right, and it's polar because toward the North Pole. Sometimes it'll be called Arctic, but that's okay. Continental polar. If it's continental polar, that tells us that continent tells us it's going to be dry. It formed over land, so it's not going to have a lot of moisture with it, but it is going to be cold. So we have cold, dry air coming, and if this comes down from the north, it's going to get things cold, but it's probably not going to bring any moisture with it. We have those fairly often in the wintertime. Now, if it were to come off maritime, which means ocean basically, so this is going to be wet, has a lot of moisture dissolved in it, and cold. A wet, cold maritime polar, or maritime Arctic, one over here just a little farther north is called Arctic, but we're just going to call it maritime polar for the sake of easiness. These, when they come down, are going to have cold air, but they may also have moisture associated with them, and therefore are likely to have winter storms and so forth like that. Okay? Now, if it comes from south of us, okay, they're called tropical rather than polar. All right, and once again, if it's over Mexico, this would be an example of continental tropical air that's coming up from Mexico. If this air comes up, continental means it's going to be dry. Okay, tropical means it's going to be warm. Okay, we think of tropical rainforest, but in this case, tropical just means warm. Okay, the rainforest means wet. But so in this case, it's continental, so it's dry, warm air, and this is going to make it hot and dry. And we get a lot of this in the summertime, and so we have air masses moving up from Mexico, and we just have hot, dry weather. Okay, on the other hand, if it comes out from the west coast, or you may even cut across Mexico, but if it comes from out of the ocean, or same thing on the east coast, Gulf of Mexico, a lot of time we talk about Gulf moisture coming in. If it forms, this air mass formed over there, it's maritime, which means warm, wet again, because it means ocean. Tropical means it's warm. So now we have wet, warm air. Now, if we have wet, warm air here and we have cold, dry air meeting here, we could have a storm, because basically storms and weather is a lot of the weather, exciting weather anyhow, the rain and tornadoes and hurricanes and all that stuff happen when these different air masses hit each other, and when one air mass hits another air mass, that's called a front. So a front is just where two of these air masses collide, and like I said, very often that's when we have the more exciting weather happen. All right, so what we need to talk about, and the next time we'll talk about, you've heard of cold fronts and stationary fronts and occluded fronts and stuff like this, and you'll hear those very commonly on the news. That's what we're going to talk about on our next and final video.